My 1989 Honda Accord Aerodeck is a pretty rare car nowadays, and as with many unsung suburban hero cars from the 1980s, it's getting pretty tricky to source some parts apart from basic service items. These bumper brackets have more or less dissolved after 33 winters and a minor parking squeeze on one of them, and I can't find any to buy, not even for ready money. So I'm going to make my own and show you how I get on. I suppose I could pay a metal fabricator to do it, but then I'd have to think of something else to make a video about, and you'd have to wait even longer, so we won't do that. I haven't done any meaningful metalwork since I was at school, and I wasn't brilliant at it then. So is it realistic for a novice like me to make metal car parts like this from scratch at home? Well, at the risk of spoiling the suspense, the answer turns out to be yes, but I did learn quite a lot along the way, so this is going to be worth watching, I think. Actually, I should let you be the judge of that. Let me know what you think in the comments below. The bracket itself is T-shaped. This part goes inside the body of the car and bolts through from underneath, and this part, which is spot welded onto it, holds the bumper in place with bolts top and bottom. I only need to remake this part. This bit is thicker steel and is held up better, whereas in the body of the car and not as exposed to the elements as particularly the bottom here. So I need to remake this out of sheet steel and separate off these spot welds, clean up this bar, put the new one on, and then spot weld it back up. When I talk about spot welds, they're not really spot welds. I don't have a spot welder. I'm doing all this with a MIG, so they're plug welds really, but they behave in much the same way as spot welds do from the factory. The first thing I need to do is measure everything. I'm measuring everything with this digital vernier caliper, which looks very fancy but actually wasn't very expensive, and so it's thoroughly on brand for Grand Thrift Auto. It's precise to the nearest hundredth of a millimetre, which is probably overkill, but I figure it's at least worth starting out with a Honda kind of mindset, even if it all ends up being a bit British Leyland by the time I've finished hammering, welding and folding. Then it's on to the computer. Actual computer-aided design here, not just cardboard. I'm doing it this way because there are various folds and angles, and I want to make sure that when I draw it out flat onto a piece of steel, I've got all those angles right. The software I'm using is SketchUp, which is free in this edition. It's not particularly cutting edge, but it does do a good job, and I'm familiar with how to use it, which helps. If you're new to it, it's actually pretty straightforward to use and learn, and free to download. Having drawn it in 3 dimensions and checked that that works out, I can then copy it and do another version that I then kind of fold flat in the software. Now, ideally, I should just be able to print this out at the correct scale and cut it out on paper and stick it onto the steel, but unfortunately I can't find a way to get it to print accurately at the correct scale. So I print myself out a reference copy that's about roughly 2/3 scale, and then get out a drawing board, a propelling pencil and a ruler. This feels like a completely unnecessary step, and I resent every minute I spend doing it. An alternative approach would have been to have drilled out the spot welds and then just hammered the actual metal flat to use that as a template. I decided against because I was concerned that I'd end up with a piece of metal that was kind of wavy and a bit stretched and not a very good shape to draw around, but that might have worked well, and so just different ways of skinning the same cat. So having drawn it out on paper and stuck it down to the sheet steel with some spray mount, which is basically post-it note glue in a can, I can draw around it with a fat felt pen. You can see what I mean about not necessarily being all that precision all the way through this process. Because spray mount is repositionable, I can peel it off and then stick it onto another part of the sheet of steel, and that gives me a second one because I'm going to need to make 2 of these. Don't worry, I'm only going to make you watch the process once. I cut out the basic outline with a big fat angle grinder and then finished off the fiddly little bits with a cutting disc on my Dremel. Then I marked and drilled the holes for the spot welds and for the bolts where the bumper bolts into it at either end. I figured this would be easy to do while it was still flat rather than trying to get a complicated folded shape under my pillar drill. Now my next challenge is that the original has a bead around the edge where it's folded over a bit to give it more strength, and I've got to reproduce that. I could do it by putting it in a vise and going around with a hammer, but that seems a bit barbaric, and it gives me an excuse to buy some more kit, in this case specifically a bead roller. I'm going to need this anyway, possibly for other bits on Honda and definitely for Project Rancho that's coming up next, so I thought I might as well get it now and start using this as a bit of practice. I'll do a separate video on the bead roller because I think it would benefit benefit from a bit of pimping up, although it does do the job reasonably well for now. It takes a bit of getting used to, mainly because you need to feed the thing carefully through with 2 hands at one end while cranking the handle, which is at the other end. So you kind of need 3 hands or 2 people, but I only had 1 person, which is me. So I probably didn't do the neatest job, but it does work. I allowed a bit of extra margin on the width so that the bead roller had something to grip onto. I probably wouldn't have had to do that if I'd had the right sort of rollover dies for the bead roller, but at some point the tool buying has to stop, so I did it this way and then just trimmed off the excess afterwards. It's good and strong, and let's bear in mind this is a bumper bracket that nobody is ever going to see again unless something's gone horribly wrong with the car. You have to do the beading before you fold the sides up, otherwise, because it's a U shape, while you're trying to put the bead on this bit will just be fouling the bead roller. So you do have to spend some time thinking through the correct order of putting all this together. Then I need to put the folds in it to give it its 3-dimensional shape. I can't do this on the metal folder because the shape is too complex and it'll just get in its own way. So the bead roller comes into its own again here. I can use it to roll through and make effectively like a score mark and a little fold by lifting it up and putting some tension on the steel. I can do it with a couple of passes. I'd probably do it in fewer passes if the bead roller was a bit stronger, which is one of the ways in which I think I can pimp it up. But by doing it not too tight and multiple times, you can get the same effect. And that worked pretty well and gives me a reasonably precise crease to fold along so that I don't lose too much of the accuracy of the shape and dimensions and do end up with something that's roughly the right size. I need to weld on these captive nuts. I struggled a little bit with this. Holding them in place was tricky. I used these neodymium magnets, but they're not super strong to keep it in exactly the right place. I think I probably need some sort of a fine precision clamp to hold things in place like this. Then it's time to cut out the spot welds. I did this using a air-powered finger sander rather than a spot weld drill. I have now ordered a spot weld drill bit, which I'll probably use on the second one and see how that goes, if it's any better. But the finger sander did the job. The original bracket did get very chewed up in this process, probably because I didn't drill the spot welds cleanly enough. But it does mean that I'm pretty glad that I'm not reliant on this for hammering flat and becoming the template to draw around to make the new one. The part of the old bracket that I'm going to keep needs cleaning up, and for that I've got another piece of kit that I'm going to find useful, which is a super cheap blast cabinet from SGS Engineering, the cheapest one I could find. That's probably something I'll do a separate video on as well, but suffice it to say it did the job nicely and gave me some clean steel to work with, so I can line up the 2 bits of my new bracket alongside the old bracket from the other side and make sure that I'm welding it in the right place. I have of course drilled the holes for the spot welds slightly in the wrong place, but that's not the end of the world. I can just drill new ones and leave the holes there as holes. Nobody's going to see this. If I was bothered I could weld them up again, but I'm not. It's a bumper bracket. So all the care I took about making sure I drilled the holes before I did any folding has kind of gone out the window because I'm having to drill holes after I've done all the folding. It is doable, though I do stand by my original plan because it is slightly harder to fit the thing under the pillar drill and keep it steady than it was doing it all on flat sheet steel before I did the folding. I've covered this in primer before I've done the spot welding so that it doesn't go rusty in the shed, because there's a few days of very wintry weather in between getting a chance to do this as I fit it in around work. Because I still need to weld it up, I've used weld through primer, which contains metal particles, in this case zinc, so that it's conductive and can be, well, welded through. I also wanted to get some level of protection in between the 2 separate sheets of metal that I'm spot welding together. This is obviously a rust trap, so any surface that I leave unprotected is going to be very vulnerable to spray that gets kicked up at the back of the car. I'm obviously going to put some top coat on this as well, which will hopefully get into the gap at least a little bit if I try and make sure and spray it that way. Overall, I'm hoping that this will stay nice and protected, and probably better than what looks like just basic powder coating that Honda gave it from the factory. The spot welding itself is straightforward enough, fair amount of power and a bit of wire feed on the welder and just fill in the little holes really. It's quite thin metal and I was keen not to blow holes in it, so I tended to do it by amalgamating a bunch of little individual tacks. I'm getting a lot more confident with the welder, and this is all good practice for the weldathon that's coming up when I finish the rest of the Honda wheel arches. I also need to weld up these edges. Because it's thin-ish steel, I'm doing it a dot at a time, stitching it together with individual tacks spaced apart so that I don't get too much heat into the metal and warp it. You get a whole row of them and they join up and form one continuous weld. This went pretty well. I've not done this before, so I'm happy with how it's gone. There's no obvious warping and there's very little in the way of little holes. You can't see daylight through. I linished back the welds with the flap disc on the angle grinder, and this showed that one of the edges where the sheets of metal hadn't butted together quite evenly, there was a bit of overlap, hadn't had very good penetration, so I quickly ran along and redid that bit. Finally, it's time to give it a trial fit on the car, and I can see that where I've beveled over this edge, it's a little bit too thick, so I just need to cut that back. And then we're good to go with a final coat of primer. I'm very happy with this. It's strong, it's solid, it's a good fit, it lines up against its friend from the other side. Once it's had a coat of stone chip on it, I think it's going to be pretty rust proof, certainly no less so than what was on there from the factory. It's been really rewarding. It was fun to do, it's an interesting challenge. I've learned a whole load of new techniques, and I've got a big lump of car part that wasn't there before. And more than that, it's given me confidence that if I look at something like the Rancho, which is full of rust, but fundamentally it's just made up of bits of folded and bent metal like this is. So if I can do this, I can fix that. I have the technology. I can rebuild it, and hopefully it won't cost me $6 million. Does that make any sense at all?